Guys, I hope you all are doing well. So today we are going to start gravitation chapter, which is important for both IIT, JEE and NEET. So JEE, IIT, JEE and NEET. It is going to be important for both the examination, and mostly they will ask question from this topic. So it is an important topic for IIT, JEE and NEET. Means in advance they will ask very less question about gravitation. So let's start the gravitation first. Okay, and if you have already covered electrostats, then it will be more easy to understand gravitation, because almost same concept we are going to use in gravitation. Okay, so let's start without any further delay. So first we are going to learn Newton's law of gravitation. So what is Newton's law of gravitation? So Newton's law of gravitation tells you that any two bodies which are having mass m1 and m2, which I am representing here, and they will have some distance between their centers r. So the every two body which are having mass and some distance between them, there will be a force of attraction between them, and that force of attraction will be directly proportional to the product of their mass, and this force will be inversely proportional to the distance between their center. Okay, so this is the Newton's formula for gravitational force. Now if you remove this proportionality sign, m1 m2 by r square, so if we are removing this proportionality sign, I am writing a proportionality constant which is g m1 m2 by r square. So where g is known as gravitational constant, universal gravitational constant. Okay. Its value you have to remember, that is 6.67 into 10 to the power minus 11. And now unit also you can remember, but sometimes students might forget unit, so I will help you how can you remember unit. Suppose we have to find unit of g, so you can rearrange this formula f square f into r square by m1 m2. Now remember what are the SI unit of these all. So SI unit of force is Newton. For distance between their center we will write meter square, and for mass and mass means kg square. So you can write unit like this if you forgot. Okay, so this value of universal gravitational constant that you must remember. Sometimes they won't give. Okay? So it will be easy if you remember. So now we have to see some more things about this. Let me choose. So first thing, this gravitational force is attractive. Okay, so it will be always attractive in nature. So suppose you are observing from m1 mass. Observing means you are on m1 mass. So how this m1 will attract this m2? It will attract with the same force. So force will be m1 m2 by r square, but it will attractive, so means it will be in this direction. Okay, or you can say the direction of force will be always line joining two masses. Okay. So if I'll join these two masses, means this is the line joining between these two masses, so force direction will be this. So m1 will attract m2 in this direction, and if you are observing from m2 will attract in this direction. Okay, so I can say force on 2 by 1 will be in this direction, force on 1 by 2 will be in this direction, but magnitude will be same. So third point I can write, force on 1 by 2 will be equal to force on 2 by 1 in magnitude, and direction will be opposite. Okay, so these things, these are few points about gravitational force you have to remember. And along with this you should remember, you must have studied that what is conservative and non-conservative forces. So gravitational force is conservative in nature. Conservative means it will depends upon the final and initial position. Okay. It won't depend upon the path. So path independent. path independent. Okay, and you can also remember they will be in pairs. Okay, it will be in pair. And one more important point. Okay, there are two objects in this example I have taken, but Newton law of gravitation says you take any two objects which are having masses and which are having some distance in between them, they will always attract. There will be always attractive force given by this formula. Any two objects you take in this universe, okay, means the room in which you are studying, the chair, the table, the water bottle, the notebook, the book, everything is attracting each another object which is having masses, and there will be some distance between them. So suppose I will take 2 or 3 objects. So this is m1, this is m2, and this is m3. Okay, so every object will be attracting each another object. So m2 will attract m1 along their line joining, so it will be like this, and m2 also attract m3. Okay, so like this. Okay, and same way m3 is attracting m2 and m1 is attracting m2. So if I'll say that these two are fixed, if I'll do m3 and m2 are fixed, so means now m1 and m3 are attracting this. So you can write total attraction force on m2 is force on 2 by 1 plus force on 2 by 3. Okay, so you can write, and this will be a vector, force vector like this. One is like this, one is like this. This is f2 on 3 and this is f1 on 2. Okay, so this will be a vector. And what is this thing called? This is nothing but superposition. Means you can always write. Okay, so what is superposition principle? If there are more than 2 points object, then the net force on any particular object is equal to the vector sum of forces to all the other object. Okay, so here you must remember this is a vector sum. Okay, so then we can apply the laws of vector, how we are adding two vectors. Okay, triangular law of vector addition or parallelogram law of vector addition. Okay, I'll do one question after this. So I hope these points you have to remember. What is gravitational law of what is Newton law of gravitation? That is G force equal to G m1 m2 by r square, where m1 m2 are masses of object, r is the distance between them, and it will be always attractive. Direction will be always towards the line joining their masses, and it will be attractive force and same magnitude. With the same force they will attract each other. Okay, it is a conservative force, it will act in a pair, and suppose you have more than 2 objects, you can apply superposition principle. Now we will go for an example. Okay, so now here is one example where 3 point masses m are placed on the equilateral triangle of side length A, and you can see A, B, C is a triangle where C, the masses on C and B are fixed. Okay, why they are fixed? Because they shouldn't move. Okay, so means we have to find here the net gravitational force on mass placed at A. Okay, so see this how we are going to do. Now you have observed this. Okay, so first only see these two particles, m1 this mass at A point and mass at B. Okay, so how this mass at P point will attract mass at A point? It will be attracting on this line, because we know gravitational force is an attractive force and it will act on the line joining their masses. Okay, and how C will attract? Like this. So between A and B, for A and B, can you write force on A because of B, gravitational force? That will be given by G, mass of one particle, mass of second particle, and distance between them. So G, mass are same, so m into m, so r square is given as A. So this will be FAB. And same thing you can see that how C will attract. Okay, with how much force C will attract, it will be also same, because same mass are there and it is equilateral triangle. Okay, you can see direction is different but magnitude is same. Okay, so magnitude will be same, so I wrote this. Okay, so I can say FAB magnitude is same as F AC vector, and this is I am writing magnitude. Okay, I am letting it as a total force F magnitude of this, or I can directly write F. Okay, that you know now. Okay, so one F is here, one F is here, and because it is equilateral triangle, this must be 60. Okay, so now you have to find how much is total force. Okay, so this is F, this is another F. Now you have to add them like a vector. So suppose there are two vectors A and B. How will you add if there is angle theta between them? So you will use the resultant formula equal to a square plus b square plus 2ab and cos theta. So same thing we are going to do here. These both are vectors. So f net resultant will be, because both are f, okay, f square plus f2 square plus 2f into f and cos of 60. So I can write like this. So can you take f common, the f square common? F square will come out of the root, so it will be f. So 1 plus 1 plus 2 into cos 60 is, cos 60 value is 1 by 2, so it will cancel. So it will be f root of 2 plus 1, means it will be f root 3 in Newton. Okay, don't forget units in physics. Okay, because every physical quantity is defined with the numerical value and unit. Okay, so don't forget unit behind this. So now we found that f net on a particle will be root 3 times f into n. You can put value of f, root 3 into g m by a square Newton. Okay, this will be your f net. Okay, we solve this question. This will be total force on this particle. Again you can see this particle will attract in this direction, this will be attracting in this direction. So resultant will be somewhat here. Okay, so resultant magnitude we found. Okay, you can also find the direction also, and if you remember using this same, how will you write direction? Tan alpha will be b sin theta plus a plus b cos theta. Here a and b means in this vector, this is f, this is also f, this is 60. So if you want to find resultant direction, this is resultant that you found value. Okay, f root 3 n. So what will be angle alpha for this? So to find angle alpha, we can again do this. So in place of b and a, we have both f. So f sin theta sin 60. So again f plus f cos 60. So by solving this, f will cancel out. You can take in common and you can cancel out. Sin 60 is root 3 by 2, and then 1 plus 1 by 2. So it will be root 3 by 2, and it will be 3 by 2. So 2 will cancel. So root 3 by 3. Okay. Now you got tan alpha equal to root 3 by 3. You can rationalize it. Multiply and divide. Then tan alpha will be 3 by, okay, sorry, it will be 1 by root 3. 1 by root 3. 3 will cancel. Okay, then alpha will be tan inverse of 1 by root 3. So means alpha will be 30 degree. And you know, when two vectors are same, it will be 30 degree. Okay, so you found both direction and magnitude for this gravitational force. You can see now. If any doubt is there, you can still ask me in comment box. Okay, so here I have also given 3 more questions. We will solve quickly. Okay, so first question is same. Okay, similar to question number 1 we did here, this triangular question. Okay, so what we have to find here, we have to find f net on m bar. So this is m mass. So you can say these are fixed and these are fixed. So how much total force m mass is experiencing? So because of 3m mass, it will experience a force in this direction, and 2m will attract in this direction. So now you have to find force on m because of 3m, that will be equal to g m into 3m by r square is a equilateral triangle. Now force on m, this is magnitude only, Okay, so force on m because of 2m. How can you write gm 2m by a square? Okay, these two you wrote. Now you can say this is f2, this is f1, so f1 and this is f2. Now do the vector addition of these two. So f net will be f1 plus f2 vector. Okay. So you can do this similar to that. Okay. Now similarly the question can be like this also. Okay, so here you have to find f naught on 2 mass. Okay, so 4m will attract in this direction, 3m will attract in this direction, m will attract. Remember, the masses, the gravitational force will be always along the line joining their center. Okay, so this will attract in this direction. Okay, you can say this is f1, this is f2, this is f3. So f net will be f1 plus f2 vector plus f3 vector. Okay, means you have to resolve this vector. So what you can do, because this is a square, okay, you know this is a, if this is a square, this is 45. You can take help of vectors. Okay, so this will be 45. So you can say you can resolve this f3 into f3 45 means, okay, I will show it here. If f is like this, f3, so this is 45, you can say f3 cos 45. Okay, and this is f3 sin 45. This will be in minus I cap, this will be in minus j cap. Okay, and for f1 you can write this will be in minus I cap. Okay, f2 will be in minus j cap, f2 will be in minus I cap. Okay, then you can add in vector, write f1 value, f2 value and f3. Okay, similarly you can write now. Okay, I'll write for you. So f net will be f1, what will be value of f1, gm 2m into 3m by a square, and direction will be minus j. Similarly you will write for f2, so f2 will be g 2m into 4m by a square. What will be its direction? In minus I cap. Now you have taken component of f3, so f3 you can write as, for f3 what will you write? G m into 2m. Okay, doesn't matter, you write 2m into m or m into m. Okay. So a square, and its component will be cos 45 is 1 by root 2, and 1 by root 2 you can say minus j cap plus 1 by root 2 minus I cap. Now you can separately solve this. Okay, whatever you can take common, you can take common. G m square you can take common by a square from everywhere. So what is left with here? Minus 6 j cap. In second equation it will be 2 or minus I cap. Here it will be, okay, I will remove this plus sign, minus 1 by root 2 j cap minus 1 by root 2 I cap. So you can solve this. This will be your f net. You can find resultant also. Okay, let me solve it for you. So you have to combine I and j component together. So what is j total? 6 plus 1 by root 2, okay, minus j, and 2 plus 1 by root 2 is I. Okay, and how will you find the magnitude, f net resultant magnitude? You know, if there is a vector v is written as vx I cap plus vy j cap, so magnitude of v will be vx square plus vy square over root. Okay, so same thing you can do here. What will be magnitude? gm square a square. Okay. So multiply with the 6 plus 1 by root 2, minus will cancel. Okay, or you can write it square plus same thing gm square a square 2 plus 1 by root 2. It is getting bigger, but okay, so I think you are not getting this. Okay, so this will be this square and root over this will give you f net. Okay, why we are using? Because actually it is if two vectors are there, vx and vy, okay, angle between them is 90. So if you are writing resultant formula, vx square plus vy square plus 2 vx vy cos theta. So theta is 90 and cos 90 value is 0. That is why we can directly use this. So this will be your F net given by this formula. Okay. So now for any type of question, they give you the square, cube, whatever they give, you have to use this formula and you have to do it like a vector. Okay. Now there is another question where this is, you can think this is of a model also, electron model, Rutherford model, where electron is moving around the nucleus. Okay, this is same thing. So they are asking what will be velocity. So now you know there two masses are there and some distance between radius, they must radius will be r. Okay, so what will be force of gravitation between them? G m1 m2 by r square. Okay, and any particle, if any particle is doing circular motion, there should be a centripetal force. So here this gravitational force is giving centripetal force, and you know centripetal force is mv square by r. Okay, so now you can equate these two. So g m1 m2 by r square will be mv square by r. Now 1 r you can cancel, m1 is moving, so it will be m1 v1. Okay, so m will cancel, so g m2 by r root, this will be the velocity of that moving mass m1. You can relate it to the Bohr model, Bohr's model. Okay, so now any type of question they can ask, take care what you have to do. You have to write force formula and then you have to add them like a vectors. Okay, so if you want, you can take screenshot of this. Now some more types of question how they can ask. They will give same triangle also. They will give same triangle like this. Okay, and what they can ask you that there is mass m, there is mass m, there is mass m, and if you keep a test mass here at center, all these are fixed. Okay, now what will be the F net on center? Okay, means same thing, you will use this, that it will attract in this direction, it will attract in this direction, it will attract in this direction. And if this is equilateral triangle, you will say this is 30 and some side will be given, and you can solve it again. 3 vectors, it will be like 3 vectors at this will be how much? 30 30 120, this will be again 120, then again 120. So what you could have done, you will find force value and it will be same because each distance and distance from each particle is same. So F3 force are acting in like this way. So you can take a resultant of these two in this direction. Because this F and this angle will be 60, so F cos 60 will come, and for this another one F cos 60. So this will be added and F sin 60 will come here, for F sin 60 it will come. So this will be cancelled, and then you can F minus F 2 times of F cos 60 will be your F net. Okay, like this you can solve this question. Okay. Similarly, if they ask you if there is a rectangle, okay, and they can give you mass here, another mass will be here, so same tricks you have to use. Still, if you want another video on this question, I can give you, but I think hint is by the taking hint you can solve this question. Okay, it will be again like this. Okay, so if it is a square like this and masses are same, F net will be 0 on M, because every direction they will cancel each other. Okay, if it is not square and masses are different, then you have to calculate, then F net won't be 0. Okay, in square it will be 0, you can see easily. Okay, so these were the question, same type, and you can say these are easy question based upon formula and how vector addition works. But there can be a different type of question that I will discuss now. Okay, so now there is another type of question where two masses 2m and 3m are given, and in between a third mass m is kept. Okay, so you have to find net force on m. Okay, so how you can do? So first you will see the 2m mass will attract in this direction. Okay, 3m mass will attract in this direction. Okay, so force on m because of 2m will be in this direction, force on m because of 3m will be in this direction. Now you can write force on m because of 2m, that will be g mass of m into 2m by a square. It is kept at the center, okay, of line joining them. So, and similarly f mass on 3m will be g m into 3m by a square. Okay, you can say this will be 2 times of g m square by a square, and this will be 3 times of g m square by a square. Okay. So now direction, you can also mention direction. If you are writing it force, this is will be force by, this will be in minus I cap, this will be in I cap. Now you can see, now you can find F net on this, and you know, because this mass is bigger, it will, attraction force will be more, because this is proportional to their mass. And writing in vector form, you can directly do this. So Fm on 2m plus Fm by 3m, you can add. Okay, put these values. So 2gm square by a square minus I cap plus 3gm square I cap by a square. Now you can see, so it is minus 2gm, so it will cancel gm square by a square I cap. So F net will be in which direction? In this direction, F net. So F net will be here, and value will be given by this. So magnitude will be gm square by a square. Okay. So this problem can be also asked in exam. And note this problem, actually how there will be different variant of this problem, how they will ask. First you can take screenshot of this. So now another question is given like this: two masses 16m and 9m are kept at 2l distance, and we have to keep m in between them such that the total F net on this m will be 0. Means you can say F net is 0, and you know how F net will be. F net will be F on m by 9m plus F on m by 16m. Okay. So we have to decide that the total force should be 0, equal to 0. Means you can say F on m by 9m must be negative of F on m by 16m. Okay. If this is the case, then we can find what will be that. Okay. So I will imagine that it will be, F net will be 0 when it is some x distance from 9m. Okay. So if total is 2l, this will be, remaining will be 2l minus x. Now I will write force formula for that. So this is equilibrium condition. Equilibrium is total force is 0. So I am assuming this is x. So we have to find now x. Okay. Where should we place? Okay, that will be our answer. Okay. Now I can write this, I will write below this. Okay, so F on m because of 9m, that will be in this direction. Okay, so I will write g m into 9m by, what is distance between them? X square. Okay, similarly negative sign will come. Okay, or you can tell about the magnitude also. So magnitude must be this. Okay, so now you can say that what will be this force because of 16m on m, it will be g m into 16m by, what is r between them? 2l minus x square. Okay, so this is the case. Now we have to solve this thing, and we will get the value of x. And one thing, because I have taken the magnitude, you can take this sign off, because if magnitude they are equal, means we have to solve only this equation. Okay. So now you can easily cancel these things. G you can cancel, m square you can cancel. Okay. Okay, so what it will be left with, 9 multiplied with the 2l minus x whole square, 16 multiplied with the x square. So we have to solve this quadratic whatever it comes. So 9 into, you can say 4l square plus x square minus 4lx equal to 16x square. Okay, so it will be, okay, so you can solve this quadratic and you can get the answer, but rather than solving this, you can take square root on both sides. So this will be 3 2l minus x square. Okay, means I will write first. So you can take square root on both sides. Okay, that will make it easy. So 3 2l minus x will be 4x. Okay, that we can do. Okay, then it will be 6l minus 3x equal to 4x. Then it will be 7x equal to 6l. Then x will be 6l by 7. Okay, so we get x equal to 6l by 7, means this m mass is at a distance of 6l by 7. So another will be 2l minus 6l by 7. So it will be 14 minus 6l by 7, that will be 8l by 7. Okay. So you can form another picture. So this will be 6l by 7 and this will be 8l by 7. From 16m it will be this, and 4m it will be this. You can also solve quadratic, but it is a lengthy, so you can directly do it from here. So I hope you got this question how to do. So in exam they asked from 9m or 16m, and based upon this you have to answer. Okay, so you can take screenshot. Okay, so now this will be the last question on Newton's law of gravitation. After that we'll move to gravitation field, gravitation potential, energy. So this is a different kind of question where we are dealing with the elementary method, how we have to solve this question. So first I will read the question. Find the force applied by rod M to L on a point mass M1 as shown in the figure. So you can treat this M2 mass is on this line only, okay? Line of action. Okay. But until now what you have done, you have only found force between two mass, okay, any two mass, okay? But here what you have to do, this entire rod is there which is attracting M1. So you have to find with how much force this rod is attracting M1, that you have to find F net. Okay, so you can assume that every point of the rod will have some mass, so every part is attracting with some force. So then you have to total them. Okay, so if such type of question comes, what you have to do, you can assume every part is attracting, means you have to write F net as, because this suppose this is particle 1, second part 2, part 3, so F by 1, F by 2, F by 3, you have to add so on. Okay, and because these are very small, which method we will use integration. Okay, we'll write for a small element dm and then we will integrate. Okay, so same thing we are going to do. So for this you can say that if this is the rod and this is mass m1 which is given a distance from this, you take any element, small element of mass dm. Okay, so which is you also take distance from m1, suppose x is there. Okay, so dm mass, how can you write? You know that total mass by length, you can say it as a lambda. Okay, mass per unit. Okay, so lambda is mass, linear mass density. They should mention here uniformly distributed mass over length, then only you can use this. Okay, if non-uniform, they should give this linear mass density. Okay, if non-uniform, lambda they will give like lambda naught x plus b, something like this. Okay, but here no need to worry about, you only must know this. So even if you take small mass and small l, this mass per unit length is going to be same. So from this you can derive a relation, small m will be lambda times dl. Okay, so this is important, you have to write. Now you can forget about everything. You can say that there is a small dm, okay, which is kept at x distance from mass m. Can you write gravitational force between them? So you will write gm small dm by x square. Okay, that's it. If you can write this, then we can easily solve this. Okay, and direction, if you want to put this will be x and this will be minus x, means you can say minus I. And direction we don't bother because total f net will be in this direction, so no need to bother about direction. It will be only in minus I cap only. Okay, so first task is to write this for a small element. Now we have to take help of integration. Now see, this is for small mass m, and if I'll add this small mass m like this will be an entire rod. Okay, so what we have to do, this is the same method. If I'll add small mass force because of this okay, df, I can say this is small force because of small mass m. So if I'll add these small forces, and if I do integration, I will get f net. So f net I can get integration of this small force. Then you have to take care of limit. Okay, if your dx mass, what is its range? Suppose your dm is here. Okay, then what will be its lower limit and what will be its upper limit, that you have to take care. So you can see, if your dm is here, so what is minimum distance between this dm mass and m, that is given in question, that is a. Okay, so lower limit will be a, and if dm is at here, so what will be this? A plus l. So a plus l, and now you know df. Okay, so you can integrate this. Okay, that will give you total force. Okay, you understand how to take limit. So now f net will be integration from a to al. Df you can write gm dm by x square. Okay, if you are writing direction, no, you can also mention this dm. Okay, now we have to take the value of dm in terms of dl. Okay, so dl we will put. So here I have taken dl, but this means length of this, so you could have taken as dx also. So better you can replace with dx. Don't confuse with these variables. I could have taken dx also. So I will write dm will be equal to lambda times dx, and lambda is nothing but total mass by total length into dx. You can write like this also. So this value you can substitute here. So gm into m by l dx by x square a to a plus l f net. Okay, now we have to solve this integration. So take gm square by l common, dx x integration will be this only. Okay, so you can easily solve this. Minus I cap I will take out. So integration of dx minus x dx e to a plus l. This integration will give you value of, so x to the power 2 plus 1 minus 2 plus 1, and because it's definite integral, no need to put c. Then we will put limit a plus l. So it will be x to the power minus 1 minus 1. Now you can put limit. It will be minus of 1 by x a plus l. So again you can say upper limit minus, I will take common, a plus l minus of lower limit. So it will a minus l a into a plus l. Here I can write, so a will cancel, minus l by a square plus al, and 1 minus is there, so it will be plus. This integration value will be this, f net will be this. So f naught will be gm square by l minus I cap. This will be your answer. Okay, so you can see what we found. Slowly you can take recap. Okay, so small element you have to take, then you have to write force because of this small element. Then we will integrate. Okay, and take care of limit how we are taking. Okay, then this will be the answer. And sometimes they can mention that a is very larger than l. Okay, so means the rod is kept very far away from that point. Then you can neglect a also. Then your answer f net will be g m1 m2 by a square. Okay, because a is very greater, so you can neglect l. Okay, so this will be a square. So thank you for watching, and this is for this lecture. In next lecture I will be covering next gravitational field and gravitational potential. I hope you like this. If any doubt is there, you can write it in comment box. I will see and I will reply your comment. Thank you. Bye bye. Take care.